Hi everyone, welcome to AS Engineering Academy, AS Online. This is Ramesh, faculty at AS Engineering Academy. Now I am going to discuss about measurement subject related to RRB JE electrical. This is generally a diploma level exam. In this entire session, we are going to discuss about important concepts and corresponding questions. But openly speaking, in this 1 hour of session, I cannot cover the entire syllabus. Therefore, I am going to discuss about the syllabus of RRB JE electrical measurement subject, and then I am going to discuss about the weightage of this entire subject in the RRB JE electrical, and what was given in our ACE online platform, how I modified chapter by chapter, then topic by topic, one or two questions, whatever the important models are there, all types of questions I am going to cover. So this is the entire thing regarding today's session. Now, in this RRB JE electrical measurement subject, this is the syllabus given by them. So let us have a look on this. Measurement of power. The starting topic itself is measurement of power. The two in the electrical point of view, measurement of power is very important topic. The two in this single phase as well as three phase. So whatever the subject you take, network theory you take, single phase supply will be there, three phase supply will be there, or missions you take, AC missions, single phase missions, three phase missions. Even if you take power system, there also three phase lines will be there. In that, after the distribution side, etc., single phase. So everywhere the single phase, three phase is very important. In our subject, how we are going to measure, that will be covered in this measurement of power in the ACE online platform. And the two, both active as well as reactive power. And energy, measurement of energy. Sir, measurement of energy is also very common topic. In our homes, right, whatever the device we are using, that is electricity measuring device we say, that is energy meter. So with that energy meter, right, how we are going to measure, what are the construction, everything will be available in measurement of energy chapter. And then wattmeter method of 2 wattmeter method of three phase power measurement only, 2 wattmeter method. This is very important topic. In the three phase power measurement, 2 wattmeter method is very important. And then measurement of frequency, measurement of phase angle. Here we can say measurement of frequency means frequency measuring device, frequency meters we can say. Measurement of phase angle means power factor angle, therefore power factor meter also we can say. Voltmeter, both moving coil and moving iron type, means PMMC instrument and moving iron type he has mentioned clearly. And then extension of range of corresponding devices, multimeters, right? We can measure current, we can measure voltage, we can measure resistance, multiple parameters. And then Megger is the device used for measurement of insulation resistance or high resistance we can say. Energy meter, AC bridges, here measurement of energy, he has mentioned energy meter. And bridges, DC bridges will be there, AC bridges. Even though he mentioned as AC bridges, actually bridges topic means resistance measurement, DC bridges also will be there. You have CRO, nothing but cathode ray oscilloscope topic. Signal generator, CTPT means instrument transformers and their uses, earth fault detection. So this is the corresponding syllabus given in the measurement and measuring instrument subject. Generally we say measurement subject. And I would like to give you one statement here. This subject is very common subject, core subject for electrical people. Generally, many people neglect this subject by thinking it is not the core subject. No, you take any subject, any exam I can say, RRB JE, SSC JE, or any examination, or even ESC, etc. Every exam, measurement subject is very common. Even in state level examinations, GENCO, TRANSCO, etc. also, this subject is very important. And the two, in this RRB JE, we can expect 6 to 8 questions approximately, not exactly, 6 to 8 questions. So definitely it is playing the major role in the corresponding exam. The two, core point of view as well as scoring point of view, this subject is very important for electrical people. It is a core subject as well as scoring subject. Conceptual subject, you can score easily. So how the questions can be asked, what is the answer, how can we answer in a very short time, everything we are going to discuss. Right? Now, whatever the syllabus they have given, right, I modified, I framed in chapter wise in our ACE online platform, right, recorded platform. What is it? First chapter, basics. In this basics chapter, generally, we will be taking what is the meaning of measurement, right, how to represent the corresponding measured value, everything will be taken in this. Second one, error analysis. Actually, if you see the syllabus, error analysis is not mentioned separately, but if you are using any device, PMMC instrument or MI instrument or wattmeter or energy meter, if you use any device while measuring any parameter, definitely error will be occurred. Why? Whatever the value is there, that value exactly will not be available. Some difference will be there. That is called as error. So that error will be analyzed in this chapter. After that, basic instruments. Sir, what are the types of instruments? Sir, indicating instruments will be there, recording instruments, integrating instruments, and then corresponding constructions and everything will be available in this chapter. If you complete these 3 chapters, we can have the complete basic idea regarding measurement and instruments. With this concept, with this entire thing, we can start the chapter instruments. In this instruments chapter, PMMC instrument, MI instrument, and then electrodynamometer instrument, that is electrodynamometer, wattmeter, that is power measuring device, all will be studied in this chapter. And then measurement of power, separate DC power, single phase AC power, 3-phase AC power will be covered in this chapter. If we complete up to this, we will be able to measure current, voltage and power. All methods will be done. Sir, after current, voltage and power measurement, what can be the next parameter? Energy. So that is the reason why measurement of energy is the next chapter. In this way, step by step, I framed the entire syllabus, chapter by chapter. After that, DC potentiometer means potentiometer, it is a meter which is used for generally potential voltage measurement. What is the construction, what are the types, everything will be covered in this. And then instrument transformers. If you see the syllabus, CT, PT they have mentioned. CT, current transformer, PT, potential transformer. Those are nothing but instrument transformers we say. And after that, bridges. In this, DC bridges, that is resistance measuring. AC bridges, that is inductance, self-inductance, mutual inductance, frequency measuring, all will be covered here. And then CRO, cathode ray oscilloscope, he mentioned clearly, right? So what is this oscilloscope? How can we measure? Everything will be covered in this. And then digital voltmeters, right? Based on the digital signal, ADC, analog to digital converter, then the corresponding processing, what will be there, etc. 3-digit DVM, 3.5-digit DVM, all will be taken in this. And then frequency meters, signal generator, multimeter, earth fault detection. So all these are being covered in the corresponding ACE online RRBJE measurements, right? Now, so this is the simple total introduction regarding subject and subject weightage and corresponding syllabus what I framed. So this is what the thing. Now, let us start the corresponding topic now. In this today's session I told you, I will be taking 1, 2, 3 topics like that, and topic to topic, chapter to chapter, questions will be taking. But before going to the questions straight away, just let us have small discussion. Sir, what is our subject name? Measurement. So what is the meaning of measurement? Suppose I want to measure length of this body. I want to measure length of this body. So what we require? one device we require, one instrument we require. After taking the instrument, how can we measure, how can we represent that entire process is defined like this. The result of comparison means this is the unknown body, this is the scale, we are going to compare these two. Measurement means comparing. By the comparison, we are writing some result. Which parameters must be compared? One is unknown quantity, other one is known quantity. Yes, unknown quantity with the predetermined standard. What do you mean by predetermined standard? That is known quantity. The result must be always after comparison. How we are supposed to write the result means simple logic. Suppose 10 ampere, that's what the representation, or 10 volt, or 10 watts. Like this we have to represent the result. What does it mean? Result must be represented in numerical form along with the corresponding unit. One is a numerical and one is corresponding unit. These two must be required. Then only we can say measurement process is being completed. That only I gave you. The result must be represented in numerical value along with the corresponding unit. So this we are supposed to follow. Suppose if I write just 10. So is the measurement process completed? No. Why? Sir, this is 10 milliamperes or 10 kiloamperes or 10 amperes or 10 volts or 10 watts. We don't know. That is the reason why to complete the process, not only the number but also unit is required. That's why this is the basic meaning, basic phenomenon of corresponding measurement. Okay, with this idea, sir, while we are measuring the parameter, what will be the corresponding phenomenon occur or corresponding thing we are going to get means error. Sir, why error? Suppose in one circuit I amperes is there, assume that 4 amperes is flowing. Actually it is not known. 4 amperes is flowing, for example. Explanation purpose I am taking as a known value, but actually it is unknown. Okay, in order to measure this current, which we use? Ammeter. Now tell me, this ammeter is a practical device. We are measuring it practically in the practical world in the corresponding application. Now tell me, this device shows exactly 4. Is it possible? No. If this device is showing exactly 4, when the 4 amperes is available, that process is called as ideal process. If it is an ideal process, is it practically measurement? No. That is the reason why, sir, it measures or it shows approximately 4. It may be 3.9, it may be 4.1, near to 4, etc. Therefore, assume that it may be 3.9, it may be 4.1. Example. Now tell me, actual value available is 4. Okay, measured value or shown value by the device is 3.9 or 4.1. Obviously, between these two, difference is there or not? Yes, a difference is there. That's why this difference is called as error. That's what the meaning. The difference of magnitude between measured value, that I am writing as AM, M indicates measured, A is some quantity, and true value. The difference between these two is called as error. Means in our measurement practical case is being considered, definitely error will be there. But error must be as small as possible. That depends on the corresponding better designed instrument, etc. But the thing is, yes, difference between these two will be existing compulsory practically. That is what? Yes, the difference is called as error. Okay. Now, sir, what is the error representation? Error is represented with epsilon. Error is represented with epsilon. And error formula is AM minus AT. What is that? Difference between measured value and true value is called as error. So therefore, in the entire measurement subject, error formula is AM minus AT. What is AM? Measured value. AT is true value. Very, very simple. But sir, in this, which should be the reference value? So true value must be reference. Measured value depends on corresponding measuring conditions, measuring device, etc. That's why this true value is also called as reference value or also called as actual value. Measured value is also called as observed value. In the examination, any terminology may be used. So that's why actual value or true value same, observed value and measured value are same. So error formula is AM minus AT, the basic formula. Just I'm brushing up basic point. After that, relative static error, very important concept and very common question in the competitive examinations from the measurement subject. What is that? Relative static error means the static error taken over the true value is called relative static error. So what does it mean? So relative static error is denoted with epsilon r. Sir, epsilon symbol error R indicates relative. So relative static error. Static error taken over the true value. What is static error formula? As you all know, AM minus AT. Taken over, yes, taken over true value. AM minus AT by AT. Suppose if you want to find out percentage, so simply into 100. This is very important concept. Relative static error formula is AM minus AT by AT into 100. Okay. This is generally called as percentage limiting error also. This is generally called as percentage limiting error. Percentage limiting error formula is AM minus AT by AT into 100. Right? Next. Sir, guaranteed accuracy error. So what is guaranteed accuracy error means? It is the error taken with respect to full scale value. It is with respect to full scale value. It is a constant error. Formula is what? AM minus AT. This is with respect to full scale value. No, AM minus AT by full scale value. This is what the corresponding guaranteed accuracy error formula. Okay. Sir, relation between percentage limiting error and percentage guaranteed accuracy error, that is very important. So what is that? So this is the corresponding relation between percentage limiting error and percentage GE. Simple logic, you know that, but generally I'm giving the formula. So percentage limiting error equal to AM minus AT by AT into 100. Percentage guaranteed accuracy error is AM minus AT by full scale value into 100. Simple. Equation 1 by equation 2 or equation 2 by equation 1. If you simplify this, from these two formulae, we are going to have this formula. Based on this formula, many number of questions are possible in the competitive examinations where the measurement subject is available. So this is the simple basic concept revision, I can say, basic concept idea. After this, topic to topic, various questions will be taken. With the question only, corresponding concept will be revised in this session, because complete subject cannot be taken. That's why question, while solving that question, corresponding concept will be revised. So now let us start some questions here. A 400 volt PMMC voltmeter is specified to be accurate within 2% of full scale. 2% of full scale. The limiting error, what he is asking? Limiting error. If you see the options, yes, percentage limiting error. Okay. It is used to measure 200 volt. For every question, I will be giving around 30 seconds of time. You try to give the answers, then I'll check with my solution. Okay. In this, sir, full scale value, how much is the full scale value? 400 volt. Full scale value given is 400. Accurate within, nothing but guaranteed accuracy error is plus or minus 2%. How much is a true value? This is used to measure, so some value 200. So therefore, true value is 200 volt. What he is asking? Percentage limiting error he is asking. Percentage limiting error. Okay, just try to give the answer. Just try to give the answer. Yes, Prem Sagar gave the answer. Option B, sir. Okay, very good. Very simple. Percentage limiting error equal to, sir, full scale value 400 by true value 200 into guaranteed accuracy error plus or minus 2%. So answer will be plus or minus 4% is the answer. Very simple. This formula based questions are very common in the competitive examination. The two RRB JE diploma level, yes, it is very common. So what is the answer? Yes, Anita and Sagar gave that answer, option B, correct. Right? Now, let us take one more question. Same model, just for getting the confidence, I gave this. 0 to 10. Full scale value 10, guaranteed accuracy error 1%, and connected to, this is a true value. Kindly don't spend much time, simply, sir, this is full scale value, sir. This is anyway guaranteed accuracy error, and this is true value. Straight away tell me the answer. Try to give the answer. Prem Sagar, 2%. Very simple. Sir, percentage limiting error equal to full scale value 10, true value 5 into guaranteed accuracy error plus or minus 1%. So answer here is plus or minus 2%. I have not given the options. Of course, in the exam, options will be given, but just normal question I gave you. Right, Upendra 2, Anita 2, Sagar 2. Very good, very good. Right. Next, let us take one more question. Right. Looks like the question is very lengthy, but don't worry, guys. Even in the diploma level, also sometimes these type of questions possible. Okay. But if you see this question clearly, answer is very simple. What is it? Resistance is measured. Resistance is measured. All this data is to confuse you, to kill your time. This data is given. Sir, voltmeter is used, ammeter is used. Voltmeter means volts, ammeter means ampere, V by I resistance. That only measured. Very simple. And then here the maximum error possible 1.4% and 1%. Voltmeter error, ammeter error, both are given. What is asking? Find the value of error in the resistance. What is the formula? R is equal to V by I. What is the V error? Plus or minus 1.4%. What is the I error? 1%. Plus or minus 1%. Right? If percentage errors are there in the denominator operation, errors must be added. Very simple. Right? Prem Sagar, kindly check it. You are given option D, but check it. V by I, resistance. Right? What is that? 1.4 by 1. So automatically plus or minus 2.4%. Not 3.4, it is 2.4. Anita also gave that option D, 3.4. Is it? No. 1.4 and 1, 2.4. So option C is the answer. Clear? Right? Okay. Next. Instruments. Simple idea I'm giving. So what is instrument? What is instrument? Very simple. Right? The instrument is a device used to measure the corresponding parameter. So that I gave you. Instrument is used for measuring the physical and electrical quantities. So that device is called as measuring instrument. Whatever the instrument used for measuring the physical or corresponding electrical quantity, that is simply called as electrical quantity means current through that body, voltage across that body, power consumed by that element, etc. That is simply called as instrument. And the next topic here is, from this classification only, right, you may be getting the question directly in the RRB JE level. What is it? Instruments are classified into two basically. One is absolute instrument, second one is secondary instrument. The first point is absolute instruments are also called as primary instruments. Okay, absolute instruments are primary, both are same. After that, secondary instruments are again classified into indicating, recording and integrating instruments. So you are getting the question like generally, indicating instruments are dash type, primary type, first option, absolute type, second option, secondary type, third option, fourth option, none of the above or all of the above. What is the answer? Indicating, recording, integrating, all these will be coming under secondary instrument category. This type of one question is possible. Next, sir, in this indicating instrument, again two types, electromechanical instruments and electronic instruments. But these are electrical instruments, we say, these are electronic instruments. And recording instruments, whatever the recorders are there, XY recorder, right, and load flow analyzer, all these will be coming under recording type instruments. And this is very, very important question. Sir, integrating instrument, which of the following device comes under integrating category? Which of the following device comes under integrating category? That is simply energy meter. Right? Why, sir? Energy is equal to integral power into dt. Very simple. Power consumed today plus tomorrow plus day after tomorrow, like that 30 days approximately, 30 or 31 days totally cumulatively added. Integration itself indicates cumulative summation. So therefore, in our houses, in our homes, whatever the meter used for electricity measurement, that is simply integrating type energy meter is the example. And indicating instruments, ammeter, voltmeter, wattmeter, all are coming under indicating instruments category. This simple classification brush up. From this indicating or integrating or recording, etc., all these instruments, what are the different types of questions available? What are the different types of questions available? Let us see. Here, sir, for all these questions, try to give the answers. Right. The controlling torque in gravity control method. Gravity control method, what is the controlling torque formula? Right. Generally, two types of controlling torque methods are there. One is spring control method, second one is gravity control method generally. Sir, in the spring control method, what is the torque formula? That is one question. But in the gravity control method, what is the controlling torque formula? Sir, controlling torque formula in gravity control method is Tc proportional to sine theta. Tc proportional to sine theta. That too he is asking proportional to dash. So straight away direct answer. Right? Proportional to which parameter? That is sine theta. In this way, direct questions are possible. Right. Veeraya and Anita, yes, gave the answer. Correct. Sumit, Prem Sagar, yes, everyone gave the answer. Option B. Very good. Right. Next one. If theta represents deflection of pointer, the controlling torque in spring controlled instrument proportional to. Earlier question was gravity. This question is spring controlled. Okay. What is it without the options? Right? Just try to give the answer. Okay. I am showing the option. Don't worry. One is a theta. One is a theta square. 1 by theta sine theta. Simple. In this spring control method, controlling torque is proportional to theta. Straight away you have to follow, yes, this is theta. Try to give the answer. Yes, first option. Yes. Uma Prem Sagar, option A, correct. Others try to give. Slowly we will be taking numerical questions also, all mixed questions. Conceptual questions will be taken as well as numerical oriented will be taken, don't worry. Yes, Veeraya, Anita, Upender. Right, everyone is giving, says correct. Right, next question. The pointer of an indicating instrument is generally made of, in the diploma level, so and so is made up of dash, so and so is made up of dash. In that way, the questions will be there. Sir, pointer. Generally, pointer should be of light in weight or heavy in weight, means automatically pointer should be having very small weight, we can say, as lighter as possible. Which material? Just check it. Copper, silver, soft steel, aluminium. Right. Take the time. Yes, Viraya and Sumit Pawar. Before the option you gave it. Very good. Aluminium. Very nice. Yes, aluminium. Aluminium is a lightweight material. This is one of the reasons to design the pointer with the corresponding aluminium material. Right? Yes, very good, very good. In the same way you try to give the answers so that all possible questions will be revised. Right? Next question. The response time of an indicating instrument is determined by, response time means, right, after which parameter the pointer will be showing the steady state value, pointer will be showing the final value. That is the meaning. The response time. So response time depends on which parameter, which torque. Response time depends on which torque. Deflecting system or deflecting torque, damping torque or damping system, controlling torque or controlling system, support type to the moving system. First of all, if you revise the entire topic, support type to the moving system, generally not at all. So simply it is anyway wrong. Confusion between these three, because you have studied all these: deflecting torque, controlling torque, damping torque. You have studied all. But what he is asking? Response time. Response time. Be clear. Very simple. Sir, if TC equal to TD, the pointer will be reaching the final steady state position, but oscillations will be there. Those oscillations will be stopped by the damping system. Based on that damping system only, oscillations will be nullified, thereby the pointer will be reaching the steady state. So that is the reason why the straightaway answer here is, which one? Very good. Veeraya Nagula, critical damping, like that we should not say critical, actually we should say nearly critical, we should say. Generally, according to the options, best answer is damping. Very good. But Durga Prasad Chari, deflection you gave. Is a deflection giving that response time? No. TD is to move, TC is to oppose, damping torque is to stop. So based on that only response time. So automatically, yes, damping system or damping torque we can say. Right? Almost everyone gave the correct answer. Right. Let us take one more. Right. A meter has full scale deflection 90 degrees at a current of 1 ampere. The response of the meter is square law. Response of the meter is square law. Assuming spring control, the current for a deflection at 45 degrees will be. Take some 30 seconds of time and try. Take some 30 seconds of time and try. Right, option C, Prem Sagar. Right, Veeraya, Sumit, Uma 0.25. Check it, ma. Check it. That very simple. He has given that square law. So theta proportional to I square. So we can write theta 2 by theta 1 is equal to I2 square by I1 square. I2 square by I1 square. Sir, theta 1 I1 is given. What we require? I2. So theta 2 is 45. Theta 1 is 90. I2 square by I1 is 1 ampere, 1 square. So therefore, I2 square is equal to, I2 square is equal to, what is that? 1 by 2. So I2 is equal to 1 by root 2. 1 by root 2. So 1 by root 2 means 0.707. 1 by root 2 means 0.707. Right? So this is the answer. So therefore, yes, of course, many people gave the correct answer, guys. Option C. Right? Don't get confused in this. I think few students, only one student, 1 by 2 square you did it. 1 by 2 square means 1 by 4 notation. So 0.25. No, root 1 by 2 will be there because square that side 1 by root 2. So 1 by root 2 means 0.707. Yes, correct. Next. One more question. This is related to extension of range. In the syllabus, they have mentioned clearly range extension, that is only. 2 milliampere ammeter. 2 milliampere ammeter means this is the meter full scale current, that is IM we can say. Has a resistance of 100 ohm. So this is meter resistance RM. Right? Is to be converted to I. Simple logic. How much capacity we are having? 2 milli. Up to how much we are supposed to extend? 2 ampere. Okay. So how much shunt resistance? How much shunt resistance is required? This is what the simple point. Okay. So what is the shunt resistance formula? Let us write here. RSH is equal to RM by I by IM minus 1. Okay. What is RM? What is RM? 100. So therefore, RM is 100 by, what is I? 2. IM is 2 milliampere. So therefore, simply 2 by 2 into 10 power minus 3, like this. Right? Now, simply 100 by 2 by 2 milli means 2000 by 2, 1000. 1000 minus 1, 999. Here don't waste the time. Why am I solving? Means to give this point only. Sir, 100 by 90, 100 by 999. So, lot of time, unnecessary calculation, not required. Simply, sir, this is equal to 100 by 1000. In this way, you are supposed to save the time. 100 by 999 means it is approximately equal to 100 by 1000. So therefore 0.1. So therefore it should be equal to approximately 0.1. So near to 0.1, whatever the option is there, we are supposed to choose it. Sir, here 0.001, wrong. Here 1 lakh, very very high, not at all. Here 100, no way, simply 0.1, yes, undoubtedly second answer. So that's why don't waste the time by taking 100 by 999 unnecessary. No, simply 100 by 1000, simply 0.1. So near to 0.1. Right? Option B. Right? Many people give that. Yes, yes, 0.1. Option B, B. Right? M is 1000. Yes, very good. One student gave that. Yes, M is 1000. 1000 minus 1. Here M means I by IM. Right? In the place of this, you can substitute M also. No problem. I gave the straight away step. Right? Okay. Right. Next. Let us take one more question. To increase the range of voltmeter. See how I framed the question. You know, earlier question, to increase the range of ammeter, numerical. Now I am taking to increase the range of voltmeter, conceptual, so that both will be covered. Sir, in order to increase the range of voltmeter, what you are supposed to connect? Resistance in series, but high or low means high resistance in series. So therefore, let us take this here. First of all, high resistance, so low resistance is wrong, low resistance is wrong. High resistance correct, high resistance correct. Now tell me, among these two, which is correct, C or D? Okay, Uma gave that option C. Yes. Here, series and parallel anyway wrong, because voltage extension, series connection should be there. So therefore, yes, this is the answer. High resistance connected in series. Right? Next. Yes, many people gave the answer. Very good. Next question. Right. Try this, guys. Very simple question. Just try this. This is the current. A current of minus 8 plus 6 root 2 sine omega t plus 30 degrees is passed through moving iron instrument. Sir, moving iron instrument. So moving iron instrument reads which value? RMS. So we are supposed to find out RMS value of this. Very, very simple. So therefore, moving iron instrument means it reads RMS value for which supply? AC supply. AC is given, MI instrument reads RMS value. Over. Very, very simple. Now we are supposed to find out RMS value. IRMS is equal to, okay, many people gave that option C, 10, 10, 10. Very good, very good. Right. Sir, root of whatever the constant portion is there, minus 8 square. Whatever the IM sine of something, so maximum is there, that you have to take maximum by root 2 square. So simply 8 square plus 6 square root. So answer here is 10 amperes. So therefore, yes, 10. Right? Very good. Yes, everyone is giving the correct answers. Very nice. Kindly prepare in this way. You can score 6 questions means 6 you can answer. 8 question you can 8 answer. You can answer 8 questions in this subject. Right. Next one. Pick the odd man out. What do you mean by that? Which is the different type of, out of all 4, which is a different type of device. Iron, moving coil, dynamometer, wattmeter. This is watt-hour meter, which is the corresponding thing. Tell me, guys. Pick the odd man out, which is a different category type of device. Right, Veeraya gave that option B. Sumit also gave that option B. Durga Prasad Chari, option D. Very nice. Right, simple. All these 3 devices are MI, moving coil, dynamometer, wattmeter. All these are coming under indicating type. Coming under indicating. But watt-hour meter, watt-hour means power into time, means energy meter. Watt-hour meter means energy meter. Sir, energy meter comes under which category? Integrating. Integrating type. So therefore, so these 3 are one category, this is other category. So obviously option D is the answer. Very good. Durga Prasad Chari gave that. Very nice. Others, don't worry. Those who have given the wrong answer need not to worry. After comparing with my answer, just correct yourself. That's it. Right. Next. Little bit lengthy, but straight away question. A moving coil of a meter. Moving coil means obviously we can say that is PMMC instrument, we can say. Moving coil means PMMC. Has 100 turns. Length and depth 10 mm, 20 mm. It is positioned in a uniform radial flux density of 200 milliweber per meter square. The coil carries, the coil carries a current capacity 50 milli. The torque on the coil is, first of all, in this PMMC instrument, what is the torque developed or deflecting torque produced formula? B I N into A. Actually, this question looks like very lengthy, but straight away all values are given. B is given, I is given, N is given, and area also given. Right. Take 30 seconds of time and do it. Okay, very good. Viraya, yes, for your question, yes, I'll answer. Just try this question, then I'll answer. First, give me the answer for this. Prem Sagar gave the answer 200 micronewton meters. Yes. If you multiply all those, you will be getting 200 micro. Simple. All values must be multiplied. Yes. 200 micronewton meter. Okay. Got it, guys? Those who are on the line, just multiply all. Right. Okay. I am going to the previous question because one student is asking that, sir, here, small mistake, Viraya. Moving iron AC/DC, sir. Dynamometer type wattmeter AC/DC, sir. Whatever meter also AC/DC. No, whatever meter means induction type. Induction type is only for AC. Induction type is only for AC. That's what the logic. So that's why this is AC/DC. Moving coil is only DC. Dynamometer wattmeter is AC/DC, but whatever meter means energy meter. Energy meter means induction type. Induction type instrument or induction type principle is only for AC. It is only AC, not AC/DC. Is it clear, Viraya? Okay, very good, very good. Like this, you type in the chat box. Yes, I'll clarify. Right. So that's why that too one more logic is also there. If we are going for any odd man out category, first we need to differentiate based on the type. All these are indicating and then it is integrating. That is a basic classification base. We have to differentiate them. Right. Next. Right. Laboratory wattmeters are. Which type of wattmeters are there in our general laboratory applications? Viraya and Sumit Pawar, yes, welcome. Here, laboratory wattmeters are. So in the laboratory type, which type of wattmeter? First of all, moving iron wattmeter is not there. Electrostatic type, no. In the laboratory type, he is asking. Induction type, right? Induction type wattmeters are there, but laboratory type of wattmeter means which is generally used. Laboratory type of wattmeter among all means obviously electrodynamometer type. That's why in the concept also generally I use one terminology. EMMC instrument is also called as electrodynamometer type instrument, that is used as wattmeter in general in the laboratory application. Yes, that only electrodynamometer type. Very good. Everyone gave the correct answer for this. Very nice, very nice. Next. For use in AC circuit, potential coil circuit of electrodynamometer wattmeter should be actually, to confuse you, purely is given. Actually, practical applications, can we take purely? No. Purely means as high as possible in a better way, that is a meaning. Which coil? Potential coil. Actually speaking, potential coil, the moment you see the word potential coil, what should be its resistance? What should be its resistance? Very high resistance. Very high resistance, ideally purely resistive. Very simple. Right, option. Resistive, inductive, capacitive, reactive. Right, what is the suitable answer for this? Yes, very good, Uma. That Upender R plus L, okay, but he is asking purely, according to the option, purely, or we can say highly also we can say, because purely is ideal term, practically highly we can say. So automatically resistive, right? Very good, Veeraya, you gave the perfect statement. Yes, very good. Yes, Durga Prasad, XP0 means, so obviously resistive we can say. Right, very good. Right, power measurement question. The ratio of reading of 2 wattmeter readings, 2 wattmeters connected to measure active power in a balanced 3-phase load is 2:1. The power factor of the load, I am giving 30 seconds for this, just try. Same type of question we solved in the class also, and the same is also previous question. Right? W1, W2, 2 wattmeters ratio, 2:1, 2:1, and he is asking power factor. He is asking power factor of the load. Just try. Yes, one student gave the answer 0.866, correct? Yes. Be clear. 0.866 lagging, 0.866 leading, 0.866 lag or lead he has given. Let us analyze this. In this entire question, did he mention the nature of the load, either lagging or leading? Not mentioned. Either lagging or leading, not mentioned. So therefore, inductive load or capacitive load is not mentioned. Therefore, it may be any load. As it is any load, so answer will not be lagging straight away or leading straight away. So directly lag or lead can be the answer. Be clear. Few people gave that 0.866 lagging, and many people gave that option A, and Anita and Veeraya gave that option C. Yes, actual answer is option C. Okay, right, let us have the corresponding solution. What is the power factor formula? Cos phi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. Okay, right. What is the relation he has given? Ratio of the wattmeters is 2:1. Right, Durga Prasad, I'll come to you. Just let me explain this. Sir, W1 is W2 is 1:2. Nothing but W1 by W2 is 1/2. 1/2. Okay. Sir, W2 is equal to 2W1. Indirectly, this is the data he has given. Substitute. Not required, just for explanation purpose I am giving. Cos of tan inverse root 3 W1, right? W1 is, directly I am writing W1 only. W2 means 2W1 by W1, 2W1. How much value will be there? Total value here minus W1 3, root 3 by 3, 1 by root 3, tan inverse 1 by 3, minus will be there, cos of minus cos only. So simply cos 30 will be there. Actually cos minus 30, cos 30 both are same. So therefore 0.866 is the answer. But many people doubt is, sir, generally, yes, Durga Prasad, I am coming to that only. Sir, generally loads are lagging. No, sir. Yes, your doubt is correct. Suppose if this option is not given, if this C option is not given, then sir, lagging or leading, we don't know. Therefore, among these two, which is the load popularly available means lagging, then you are supposed to take first option. But to kill your time or to deviate you, third option is clearly mentioned that lagging or leading. So that's why if lagging or leading is mentioned in the question, you are supposed to take C option, that is lagging or leading only. If it is not given, yes, your doubt is absolutely correct, Durga Prasad. Yes, lagging should be taken because mostly loads are assumed to be lagging. But in this, either this or this are given. That's why, yes, it should be taken. Is it clear, Durga Prasad? Right? That's why concept-wise as well as based on the given options also we are supposed to consider, right, corresponding procedure. Right. Next. In a dynamometer wattmeter, the moving coil is, right? In dynamometer wattmeter, the moving coil, very simple. Sir, fixed coil is the current coil, moving coil is the potential coil. Yes, so simply moving coil, straight away potential coil. And current coil is nothing but fixed coil, right? Low power factor coil, compensating coil, not suitable to this question. So straight away, yes, potential coil is the moving coil. Correct? Next. The power expression in three-phase circuit in terms of line voltage is VL, line current is IL, power factor of the load is correspondingly cos phi, and the power is like this, where phi is the angle between, or I can say here, power of the load is like this, we can say, no problem. Sir, the phi is always between. Electrical engineers should remember this basic point. Always the corresponding phi will be in between. Whatever the phase angle is there, whatever the power factor angle is there, that should be always between phase voltage and phase current only, but not line. If it is star or delta, terminology may be changed, but basic concept is always the power factor angle, that is phase angle, is always to be taken between phase voltage and phase current only. So therefore, yes, which is the answer? Yes, option D is the answer. But to confuse you, VL, IL, cos phi, root 3, something is good. What we think? Okay, phi, angle between VL and IL. No. Phi is the angle between phase voltage and phase current. We should not take line at all. I know many people gave that. Yeah, many people means Suresh gave that option A. Generally we think line voltage, line current. No. Basic approach is phase voltage, phase current only, because load must be generally taken per phase notation. Power factor, yes, per phase notation. Angle, power factor angle, V phase, I phase, between those two only. Right? Not line. Anyway, no confusion. Between these two, no confusion will be there. Only A option or D option. Generally, confusion will be there. But answer is phase voltage and phase current only. Right? Next. Right. This is very, very simple. The instrument whose deflection is given by the equation theta proportional to I square dm by d theta is known as, simple, dm by d theta. dm by d theta. M, mutual inductance. M, mutual inductance. In which device we are going to get mutual inductance? Simply check it. Repulsion type, Mi. electrostatic, capacitance type, attraction type, it is also Mi. In all this, in this self-inductance, electrostatic capacitance only. In which case mutual inductance will be there? Respond. Yes, obviously, correct, Veeraya. Electrodynamometer. Electrodynamometer is the answer. Right? Next. The minimum number of wattmeters required to measure three-phase power is. Sir, in this question, he has not mentioned, right, what is the type of load? Is it a star-connected load or delta-connected load, balanced or unbalanced? Nothing is mentioned. Simply, three-phase power measurement. How many number of wattmeters required? The two. Minimum he is asking. Minimum. Simple. 0 is anyway not the answer. Sir, 3 wattmeters you can use. Then neutral wire is a 3 you can use. So 3 you can use or 2 you can use. So which is the minimum? So straight away 2 is the minimum, undoubtedly. Yes, very good, very good. Veeraya, PM Sagar, Upender, Anita, Likhita, Suresh, Uma, Durga Prasad, Veeraya. Everyone gave the correct answer. Very nice. Now let us take one more question. In 2 wattmeter method of power measurement, when power factor is unity, it is straight away question. Power factor is unity. The readings of 2 wattmeters W1 and W2 are. In the concept also I have taken, if 2 wattmeter readings are dash, then the power factor is unity, etc. What is it? See the options. Tell me. Durga Prasad, yes, correct, but nothing is given, no. Minimum is 2. Okay. Yes, wattmeter, so power factor is unity means wattmeter readings will be, yes, W1 is equal to W2. Option C is the answer. If both wattmeter readings are equal, correct. Very nice, very nice. Right? Now, let us take one more question. Right. In a single phase energy meter, the magnet which controls the speed of the aluminum disc, it's very, very simple. Which magnet will be used to control the speed of the disc? Which magnet will be used to control the speed of the aluminum disc? Tell me, guys. Definitely. Series magnet, shunt magnet, these are for operating torque. Shading band also to get 90 degrees notation or near to 90. But it is to control the speed means obviously brake magnet is the answer. Brake magnet is the answer. Right? So these are the few important concepts and corresponding questions in this today's session. Yes, many people gave this. Yes, correct? Right. Now, so we are at the end of the session. So almost topic to topic important questions I have taken. Like this only, as many as possible questions kindly practice. The 2 RRB JE measurement questions are very simple. In this fashion will be there. Even the numerical questions are there, direct multiplication or conceptual questions will be basic fundamentals only. So kindly prepare well. All the best, guys. Thank you.